in the old days, we had the discussion in first hour how that's a relative term. Charlie asked me about in the old days, and I'm a little offended by that. He thinks like in the old days was when I was in high school. When I think in the old days, I think like no cars, you know. But he just thinks no smartphones, I think. All right, in the old days, like when they had to like ring up the operator to make a phone call, okay, that's what I mean by in the old days. There was a probability of 0.8 of success in any attempt to make a telephone call, okay? So I'm going to write the probability of a success. I'm going to call that my P here. Successful call is 0.8. The probability that the call will fail or not go through then would be what? 0.2. Good. Says calculate the probability of having 7 successes in 10 attempts. Okay, so what is N? All right, so let's set this up then. I'm only asking for the probability of having 7 successes. Somebody tell me what I should do first. 10C7. What else? I want to count 7 successes, so I'm going to raise 0.8 to the 7th, which means if there is 7 successes, how many failed? 3. So I rate the Q to the 3rd power. Would you do that, please? Do you get 0.201? Okay. While we are figuring this out, let's talk about what we round to, because really, there's 3 ways you can write probabilities. You can write it as a fraction, you can write it as a decimal, or you can write it as a percent. Typically, those are the 3 accepted ways. Right now, I'm going to stay consistent with 3 decimal places. Really, the only thing you got to be careful of is sometimes you're going to get a probability that's really, really high. Like maybe it would be 0.999999125 or something like that. Normally in a math class, you would round that to what? To 1. But when it's probability, why wouldn't I want you to round it to 1? Because it isn't exactly 100%. We need to indicate somehow that we understand that that's not 100% likely to happen. Okay, so that's the only thing you really want to be careful of with rounding, is when you get things that are really close to 1. Okay, in number 3, let's try to find out P and Q here. Let's say that P is the probability that the marksman is going to hit the target. What is the probability that he's going to hit the target? Once again, it's 0.8, right? Or 4 out of 5. And the probability he's going to miss the target then would be 0.2. Okay. What's the probability he has more than 2 hits? Well, how many trials were there? 4. So would you tell me, what does it mean to get more than 2 hits? To get 3 or 4? So in A, I'm going to find the probability of 3 and the probability of 4 and add it together. Okay. So for the probability of 3, I'm going to take 4C3. Can you guys see that in the back okay? Okay, 4C3. That means times 0.8 to the 3rd because there's going to be 3 hits times 0.2 to the first. And then to calculate 4 hits would be 4C4, but do I need to write down 4C4? No, because 4C4 is just 1. And it would be 0.8 to the 4th power, 0.2 to the 0 power. Do I need to write down 0.2 to the 0 power? No. Okay. Would you calculate that for me? Okay. What did you get? Don't be shy. Thank you. 0.819. All right. What does it mean to say at least 3 misses? You could think of it as doing hits, or you could think of doing 3 misses or 4 misses. What I'm going to do is count the misses, and I'm going to count 3 or 4 misses. Okay? So this is the probability that I'm going to want to raise to the 3rd and the 4th power. So the ways to count 3 misses is 4C3, but this time I want to raise the probability of getting a miss to the 3rd power. If the marksman misses 3, that means how many does he hit? 1. So I'm going to raise 0.8 then to the 1st power. And then I need to do 4 misses. 4 misses is 4C4. Don't need to write it down. The probability of 4 misses is 0.2 to the 4th, and I don't raise 0.8 to anything. Well, I do. I raise it to the 0, but that's just 1. All right, so what do I get for that? 0.027. All right. Finally, number 4. A manufacturer of metal pistons finds that on average 12% of its pistons are rejected because they are either oversized or undersized. So the probability of a reject is then 0.12. Okay. You want that. What is the probability that a batch of 10 pistons, so that would be my number, will contain no more than 2 rejects? Well, what does no more than 2 rejects mean? No more than 2. That means 2 or 1 or 0. So to do A, we're going to add those together. Oops. P of 1 plus P of 2. Okay. The probability of 0 rejects. Somebody tell me what that is. If there are 0 rejects, that means 0.12 is raised to what power? If there are 0 rejects, to the 0 power, that means 0.88 would be raised to the 10th. Okay. For P of 1 reject, it's going to be 10C1 times 0.12 to the first times 0.88 to the 9th plus the probability of 2 rejects is 10C2 times 0.12 to the second times 0.88 to the 8th. Okay, so I do that. And I get 0.891. Okay. Questions so far? What's this question asking? At least 2 rejects. That would be the probability of 2 plus the probability of 3 plus the probability of 4 plus all the way up to what? Probability of 10. From yesterday, I gave you a way that would be less work than that. What, especially since I already set these up, what would be easier? What's the only thing that's not included in this probability? 0 and 1. So it would be less work because the entire distribution has to add up to 1. This has to equal 1 minus P of 0 and P of 1. And I know I didn't save those answers, but P of 0 and P of 1 I set up here, didn't I? So let's just add P of 0 and P of 1 together from above and subtract it from 1. Okay. When I do that, I get 0.342. The probability that I would have at least 2 rejects.